Hello, and welcome to my channel. Today, we're going to take an in-depth look at how the universe began and how the Big Bang Theory explains this beginning. The Big Bang Theory is one of the most widely accepted theories about the origin of the universe. However, this theory is just a starting point, and we need more information to go beyond it, to understand the true nature of the universe. If you're ready, let's start exploring this fascinating topic. The Big Bang Theory. Basic principles. What is the Big Bang? The Big Bang Theory proposes that the universe began expanding from an incredibly dense and hot point about 13.8 billion years ago. This theory was first proposed by Georges Lemaitre in 1931. This theory, which explains the beginning and expansion of the universe, explains many phenomena in the observable universe. Expansion of the universe. One of the most important components of the Big Bang Theory is the idea that the universe is constantly expanding. In the 1920s, Edwin Hubble discovered that distant galaxies were moving away from us and determined that the speed at which they were moving away was directly proportional to the distance of the galaxies. This observation is known as Hubble's law and is direct evidence that the universe is expanding. Redshift. According to Hubble's observations, light from distant galaxies reaches us redshifted. This redshift indicates that galaxies are moving away from us and the universe is expanding. The lengthening of the wavelength of light is associated with the expansion of the universe, a phenomenon known as the Doppler effect. The Big Bang Theory. Evidence. Cosmic microwave background radiation. In the 1960s, Arno Penzias and Robert Wilson discovered a radiation left over from the Big Bang that is found everywhere in the universe. This cosmic microwave background radiation (CMB) is considered to be radiation from the early universe. The CMB is one of the strongest pieces of evidence confirming that the universe is expanding from a hot and dense point. Element distribution. The Big Bang Theory also explains the distribution of elements at the beginning of the universe. According to the theory, in the first few minutes of the universe, light elements such as hydrogen, helium, and a small amount of lithium formed in a process called nucleosynthesis. The observed distribution of these elements is consistent with the predictions of the Big Bang Theory. Homogeneity of the universe. The fact that the universe is homogeneous and isotropic on large scales is another important proof of the Big Bang Theory. The fact that similar structures and distributions are seen all over the universe supports the idea that the universe was very small and homogeneous at the beginning. Limits of the Big Bang Theory. Singularity problem. The Big Bang Theory posits that at the beginning of the universe, there was a singularity of infinite density and temperature. However, infinities in the physical sense are not realistic. The singularity shows the limits and shortcomings of the theory. At this point, the general theory of relativity loses its validity and new theories, such as quantum gravity, are needed. Dark matter and dark energy. The Big Bang Theory explains the expansion and large-scale structure of the universe. However, it cannot fully explain the nature of dark matter, which makes up 27% of the universe, and dark energy, which makes up 68%. These mysterious components significantly affect the expansion and structure of the universe. Inflation theory. The Big Bang Theory cannot fully explain some observations. For example, it struggles to explain why the universe is so homogeneous and isotropic. To overcome this shortcoming, inflation theory was developed. Inflation theory suggests that the universe underwent a period of very rapid expansion at the beginning, and that this expansion explains the homogeneity and isotropicity of the universe. Inflation theory. What is inflation? The theory of inflation proposes that in its earliest moments, in a very short period of time, the universe experienced an incredibly rapid expansion. This expansion makes the universe homogeneous and isotropic. This theory, proposed by Alan Guth in 1981, complements the shortcomings of the Big Bang Theory. Evidence for inflation. Inflation theory explains small fluctuations in the cosmic microwave background radiation. These fluctuations are caused by quantum fluctuations at the beginning of the universe that propagate to large scales during inflation. These fluctuations in the CMB explain the large-scale structure of the universe and the formation of galaxy clusters. Consequences of inflation. Inflation theory draws important conclusions about the shape, size, and structure of the universe. Inflation predicts that the universe is flat and infinite, homogeneous, and isotropic on large scales. In addition, inflation theory determines the expansion rate and energy density of the universe. The discovery of dark energy. In the late 1990s, observations of distant supernova showed that the expansion of the universe is accelerating. This acceleration is caused by a mysterious form of energy called dark energy. By accelerating the expansion of the universe, dark energy adds a new dimension to the Big Bang theory. The nature of dark energy. Very little is known about the nature of dark energy. However, it is known to make up 68% of the universe and accelerate its expansion. Dark energy can be described as a cosmological constant or a dynamic field quintessence. This mysterious form of energy determines the future fate of the universe. Dark matter. The discovery of dark matter. Dark matter has been proposed to explain the gravitational behavior of the universe. The rotational speeds of galaxies cannot be explained by visible matter alone, and therefore the existence of dark matter is needed. Dark matter makes up 27% of the universe and influences the formation and structure of galaxy clusters. The nature of dark matter. There are various theories about the nature of dark matter. Weakly interacting massive particles WIMPs are one of the most popular candidates for dark matter. Other candidates, such as MACHO's massive compact halo objects and axions, are also being explored. However, the nature of dark matter is still a big mystery. The future of the universe. Big freeze. If the expansion of the universe continues, the future fate of the universe will be the Great Freeze. Dark energy accelerates the expansion of the universe, causing galaxies and stars to move away from each other. As a result, the universe cools and stars go out. This scenario predicts that the end of the universe will be cold and dark. The Big Rip. If the influence of dark energy increases, the universe could face a scenario called the Great Rupture. In this scenario, dark energy accelerates the expansion of the universe, becoming powerful enough to tear apart galaxies, stars, and even atoms. As a result, the universe would completely disintegrate. The Big Crunch. If dark energy weakens over time, the universe could end in a scenario called the Big Collapse. In this scenario, gravity becomes dominant and the universe stops expanding. Then, all the matter of the universe would gather in one spot and collapse, ending in a Big Bang. Alternative theories of the beginning of the universe. String theory. String theory proposes that the fundamental constituents of the universe are strings. This theory aims to unify quantum gravity and general relativity. String theory offers a new framework to explain the origin and structure of the universe. Cyclic universe theory. The cyclical theory of the universe proposes that the universe goes through continuous cycles of expansion and contraction. According to this theory, the universe starts with a Big Bang, expands, then contracts again with a big collapse, and starts again with a new Big Bang. This cycle continues endlessly. Conclusion. Today, we take an in-depth look at the Big Bang theory and the beginning of the universe. The Big Bang theory provides strong evidence for the origin and expansion of the universe. However, this theory cannot fully explain the nature and future of the universe. New discoveries, such as dark matter, dark energy, and inflation theory, help to better understand the universe. These fascinating questions about the beginning and future of the universe continue to inspire scientists to continue their research and develop new theories. See you in the next video. Bye.